Welcome to Wormhole to Cosmos. Today we explore Intuitive Machines' IM-2 mission, a bold step towards sustainable lunar exploration. At its heart is Athena, a Nova C lander, launching aboard a SpaceX Falcon 9 to test lunar mobility, resource prospecting, and volatile extraction. Equipped with NASA's Trident drill and M-Solo spectrometer, it will search for water beneath the surface. The micro-nova hopper, Grace, will explore craters, while a rover with Nokia's Lunar 4G system tests future communications. With just 10 days of sunlight, every moment counts. Let's dive into the mission from launch to landing. Athena is on its way. The Falcon 9 propels the lander beyond Earth's atmosphere, gaining speed as it climbs. The world shrinks behind it, while the moon awaits ahead. Soon, a crucial milestone approaches, lunar vehicle separation, where Athena will begin its own journey through space. Now approaching a critical phase, launch vehicle separation. A controlled spring force will gently push Athena away from the second stage, setting it free. The lander remains in standby, awaiting confirmation of deployment. Brake wires signal the moment of release, activating a countdown. Once the timing interval completes, Athena powers on, bringing its guidance, navigation, and control, automated flight management, radios, and thermal systems online. Now the lander prepares to navigate the vast expanse ahead. Its journey to the moon has truly begun. Athena is now fully autonomous. Its reaction control system fires small bursts of helium gas, stopping any unwanted spin. At first, the lander doesn't know its exact orientation, but star trackers scan the sky, matching constellations to find its position. Using the Kalman filter, Athena refines its attitude, then tilts slightly to align its solar arrays for maximum power. This is max power attitude. With systems stabilized, Athena's radios activate, making first contact with Nova Control in Houston. Next, flight controllers will execute 3 trajectory correction maneuvers, refining Athena's path toward the moon, ensuring it arrives precisely on target. Now comes the most powerful maneuver of the mission, lunar orbit insertion. Athena fires its main engine, slowing down by 800 to 900 meters per second to be captured into a stable 100-kilometer low lunar orbit. This critical burn uses nearly 1/3 of Athena's total propulsion capability. The moon's gravity takes hold, and Athena is now in position for the next phase, preparing for landing. Athena is now in low lunar orbit, circling the moon every 2 hours. For 75 minutes, it remains in direct contact with flight controllers, but then the moon blocks its signal. This is loss of signal, LOS. For 45 minutes, Athena flies in silence until it emerges, re-establishing communication. Acquisition of signal, AOS. This cycle repeats as Athena orbits for 3 days, preparing for its final descent to the lunar surface. As it circles the moon, Mission Control has the option to fine-tune the trajectory with a lunar correction maneuver, LCM. This brief engine firing adjusts the orbit, ensuring the best possible approach for landing. The final approach begins. Descent Orbit Insertion, DOI, fires the main engine, lowering altitude from 100 kilometers to 10 kilometers near the landing site. Like a cyclist coasting downhill, the lander gains speed at its lowest orbit point before stabilizing. After coasting for an hour, Powered Descent Initiation, PDI, begins, slowing by 1,800 meters per second. Unlike other landers that pulse their thrusters, this engine burns continuously, much like the Apollo descent module. At 2 kilometers, it pitches upright, activating Hazard Relative Navigation, HRN, to scan for a safe landing zone. The system selects the best designated landing site, DLS, and gradually throttles down, adjusting for reduced mass as propellant burns. Vertical descent begins at 3 meters per second, slowing to 1 meter per second at 10 meters. In the final seconds, dust obscures sensors, leaving inertial guidance to control the descent, like walking toward a door with eyes closed. The lander gently touches down at 1 meter per second. A 15-second delay follows before mission control confirms. Landing successful. Now, the mission begins, with 10 days of scientific operations before lunar night sets in. With precision, Athena extends its robotic arm, unveiling the lunar outpost MAPP rover. This wheeled explorer is designed to traverse the lunar terrain, mapping the surface and collecting vital geological data. The MAP rover deploys its communication antennas, establishing a link with Athena and mission control, ready to embark on its exploratory journey. Embarking on its maiden voyage, the MAP rover traverses the Moon's landscape, analyzing soil samples and capturing high-resolution imagery to enhance our understanding of the lunar environment. Athena's compartment opens, revealing the compact two-wheeled Yaoki rover developed by Diamond Co. The Yaoki rover deploys onto the lunar surface, its wheels adapting to the Moon's regolith, ready to commence its mission of data collection and terrain analysis. Nearby, the micronova hopper, Grace, initiates a test hop, showcasing its ability to traverse the Moon's surface by leaping over obstacles. Grace propels itself skyward, scanning the terrain from above before landing gracefully, ready for its next leap. Venturing into the unknown, Grace approaches a shadowed crater, its lights piercing the darkness to explore regions untouched by sunlight. Meanwhile, Athena activates NASA's Prime 1 drill, delving beneath the surface to analyze the Moon's composition, searching for hidden resources. Grace takes flight again, hopping to a new site, extending the mission's reach and gathering invaluable data.